Good morning, all. So, this is your question bank from VTU for engineering visualization subject. You can see we have completed projection of points and projection of lines problem. Now we are doing projection of planes here. So the first problem here, it is a triangle. So they are not given any kind of dimensions. Okay. So we have to assume and do it. Okay, first I am constructing an XY line and writing the text here XY VPHP because projection of planes also lies in the first quadrant. So go to polygon by center, select 3 sides and take thickness 0.50. Okay, you can see here in the problem you have to take randomly the length for the triangle. I will consider 30 mm. Okay, now with respect to question, you can see here end A is in HP and B is in VP. That means we should make sure one corner touching the XY line and one corner has to be in the HP plane. Okay, I'll select the corner end and touching the XY line. This is how I'll make the one end A, it is in HP and B is in VP. So I'll be writing, so this is A and this is B. So with respect to the conditions given, so we have constructed the first position. Okay, now we have to project it to complete the front view. Take thickness 0.50 mm here. So A dash visible, B dash not visible from the front view. So C dash. So angle of inclination I will take randomly because they have not mentioned, they are telling. So we should take it from our side. So I will go to move command, creates a copy of it and slide along the line of the XY line. So we have to go to the rotate here, rotate command. Okay, select this line, select the end points here, select the end points and give the angle. So here I will give 45-degree inclination to HP. Okay, and I will measure the angle. So now project it downward to complete the second position, top view. Projecting the lines vertically downward, and we can project the lines horizontally also from A and C end. Sometimes you need to zoom in exactly to get the exact point here. So write down the notations properly. Now construct the second position here. Okay, this type of problem, it is not there in your engine graphics solution book. Okay, now you see side. So we have given side AB inclination. Now the same side AB we have to give inclination to VP. Side AB inclination we have given. Okay. So I'll be giving angle of inclination to AB here. I'll give 30 degree. Okay. Now I will take this second position top view. Go to move command, creates a copy of it and slide along the line. Okay, if you place it on that corner point, it will be, if you rotate it, so it is going to merge with the XY line, so we will avoid it. So I'll be taking that edge AB here. So go to move command, creates a copy, select the end point B here and place it on the angle line. Okay. Okay, now project it upward to complete the final position here. Then finally we have to incline that BC also. I will do that. And as per the question, I am doing it. So this is somewhat like application problem. So this type of problem not there in your solution book. Okay. So you can subscribe for the channel and turn the bell icon for the latest notification and share it to maximum students so that they can be benefited from this. So construct the final position here. Take the thick lines here to construct the final positions. Okay. Taking the thick lines we can construct easily. So that is B dash, A dash and C dash. Okay, now as per the question, now we have to give inclination to side BC. Okay, side B's inclination to HP we have to give. Okay, side B's inclination we have to give here. So in the front view, so we have to give an angle. I'll select that final position. Okay, I'll create a copy of it and slide along the line. Slide along the line here. Now we have to incline that BC with respect to the HP plane. So go to rotate. With respect to the HP we have to incline it. So I'll be inclining it. Okay, so if we check the angle for the BC, I think it's not happening properly. I will be tilting little more with respect to the right side. Okay, so that we can get the exact angle here, because in the question they have not mentioned clearly how much angle of inclination we have to consider. Okay, they have not clearly mentioned it, so we have to, I'll be tilting little more further so that it will be convenient for us to show the angle. Okay, I'll be taking again. Side BC. I'll be tilting further on that side. Okay, yes, like that I will do. I will give the angle of inclination. Angle of inclination to HP we have to give, not to the VP. Okay, I'll further little incline it. Okay, here I'll give 100. Now we'll check the angle. So the angle of inclination to BC I have given 40 degree. Now we have to find out the angle of inclination to the CA with respect to the HB. So the angle here we are getting to the HP plane, it is 22 degree. Okay, this is what we have to find out in this question. Okay, now at the end I am going to mention that angle. Okay, angle of inclination for that CA to the HP plane, it is, I'll be mentioning on it, inclination of AC or CAAC, whatever it is, AC with HP is 22 degree. Okay, so that completes the first problem. Now we move on to the problem number 2. Problem number 2 is a square lamina side ABCD of dash side rests on one of its corners on the ground. Its plane is inclined at an angle dash degree to HP and diagonal BD is inclined at dash degree to BP and parallel to HP. Draw its projection. So square lamina we have to construct with respect to corner, and it is an beta angle problem because they have given angle of inclination to diagonal here. Okay, first I am constructing an XY line and mentioning XY VP HP. Okay, now I'll go to the rectangle by center. For constructing square, you go to rectangle by center, give width and height 30-30, angle 45 degree for the corner position. Okay, construct it and make this rectangle thick. I'll be considering the thickness of 0.50 mm. Okay, now we can give the naming here. We have to make sure we have to get that BD as a diagonal. Okay, so like that I am writing the notations here, ABCD. So now we can see that, so with respect to that corner position, we are getting the BD as a diagonal. Okay, BD as a diagonal. Now we project it upward to complete the front view. Okay, do the projections. Drawing the projections, we can complete the front view. So in the front view, I'll be drawing the thick lines by at an intermediate distance. Okay, from there to there, so that it will avoid that splitting command. So B dash, A dash visible, C dash not visible, that's why it is written within bracket, and D dash. Okay, select this front view and go to move command, creates a copy of it and slide along the XY line, and then go to rotate, select the end points, select the first B dash and then D dash and give the angle of inclination 30 degree. Okay, mention the angle. Okay, now project it downward to complete the second position, top view. Write down the notations for it. Construct the second position, top view, with the thick line here. So it is constructed. Now with this problem, it is a beta angle problem, so that means we should construct the diagonals here. Okay, for the first position also I am constructing the diagonal from B to D. Okay, that's what your first diagonal length, and this is your second diagonal. Okay, in the construction of beta angle, we should use this diagonal lengths. I am changing the first diagonal naming here. I'll be giving BD1. Okay, BD1, that is your first diagonal length. Now I am constructing the angle line. Okay, angle line I will construct. Okay, angle you can give here minus 45 degree. Okay, show the angle. And measure the diagonal lengths. Okay, because we require these diagonal lengths in order to cut the arcs. Okay, so go to arc by center. Okay, go to arc by center, take first length. The first length it is 42.43 and cut the arc. That is what the first arc you have to cut. Then after that you have to construct an locus line here, where the arc you have cut it right at that exact point. So you have to draw the locus line here. Okay. Again go to arc by center and measure the second diagonal line, that is 36.74. Give the radius 36.74 and sweep. Okay, cut the arc. So cut the arc. Now join it, this cutted arc point with the reference point. You can see that. So we have joined. Now extend this using extend to next command. Okay, and find out the beta angle. So here in this problem the beta angle I am getting 55 degree. Okay, now select the second position top view. Okay, go to move command, creates a copy of it, select the end B, place it on that reference line, go to rotate, select BD and then rotate, get that exact point. Okay, click. Now project from all this reference point. Okay, do the projections from these reference points, and we have to complete the final position here. So do the projections. So construct the projections here to complete the final position here. Okay, now write down the notations here. Write down the notations. And complete the final position. Okay, join all these with a thick line. So that completes the problem. So the problem number 2 is completed. Now we are moving on to the problem number 3. Okay, that completes the square problem with the beta angle. Okay, now we are moving on to the problem number 3. Problem number 3 is a pentagon. So herein it is resting on HP on one of its sides such that it is inclined to HP. The side on which it is inclined to VP. So it's like normal type problem. Okay, so first we have to construct an XY line by taking thickness 0.25 mm. Okay, mention XY VP HP here. So now we have to construct a pentagon here. To construct a pentagon we have to go to polygon by center, and it has to resting on the HP plane with respect to one of its sides. Okay, so this is a normal type problem. So give the sides 5, go to thickness 0.50 and randomly can draw with the edge. Okay, because we have to make sure it is resting on the sides. So here the dimension I will give to 25. Okay, pentagon of dimension 25. Okay, this is a normal type problem. You all know how to construct it. There is no difficulty in this. Okay, there is no difficulty. You can write down the notations here. Mention the notations A, B, C, D, E. Okay, now project it upward to complete the front view. Front view we can construct. Do the construction here. Okay, now select the thick line 0.50 from here. From end to end you can join. Okay, so that we can avoid that splitting command. So mention the namings here. Okay, so A dash in bracket C dash and E dash in bracket and D dash. Okay, now we have to select this front view. Go to move command, select it first and go to move command, creates a copy, slide along the XY line. Okay, then go to rotate, select the end points here and give the angle. So I'll give the angle 45 degree. Okay, so measure the angle. Now draw the projection lines downward. Okay, to complete the second position top view here. So draw the projection lines horizontally also. Okay, now write down the notations. So notations you can write A, B, C, D, E. Okay, wherever they getting the intersection point, so you have to see it and then write it properly. Okay, then go to the thickness 0.50 mm thickness in the straight line and then join these exact points with the cross mark. Okay, so that we can get the exact point here. Okay, so join it. Now we have to draw an angle line with respect to VP. So with respect to VP we have to take an angle line here. So you give an angle line here, so you can give the angle. So we'll give the angle minus 45 here. Okay, we'll take minus 45 inclination to VP and check the angle, measure it. Okay, now select the second position top view, go to move, creates a copy of it, go to move command, creates a copy, select the end point A here. Okay, corner end point A. Okay, so because you have to place it on this edge, okay, with respect to the VP, that's why we are selecting AB. Okay, now we have to project it upward to complete the final position. So draw the projection lines upward here. So wherever they are merging up, we have to end it up till there. Okay, so draw the projection lines to complete the final position. So you can subscribe for the channel, hit on the bell icon for the latest notifications and share it to maximum students so that they can be benefited from this. Okay, now join all these points with the thick line to complete the final position. So join all these points here now. Okay, that completes the problem here. Now we are moving on to the next problem. So that extra lines I am going to trim it out. Okay, using a trim command and trimming off. Okay, so move to the next problem, that is problem number 4 in the question bank. So next problem, it is a regular pentagonal lamina of side dash mm has one of its corner in VP and the plane of lamina is inclined to VP. The side of the lamina opposite to the corner is, that means in this problem, so we have to construct the pentagon with respect to corner position in the VP plane. Okay, that's what your first position. Okay, so construct an XY line. So write XY VPHP because so we have to consider the first quadrant here for the projection of planes here. Okay, so go to polygon by center, select 5 sides and take thickness 0.50 and place it in the VP plane and place it with respect to corner position. Okay, and then select the smart dimension and change the dimension to 25. Okay, this is what the dimension I'm assuming it, because it's not given in the question. Now you write down the notations. You can write down E dash, B dash, C dash, T dash, E dash. Okay, write down the notations properly. Okay, draw the projection downward to complete the top view here. You can subscribe for the channel, hit on the bell icon for the latest notification, and share it to the maximum students so that they can be benefited from this. So write down the top few notations. Here B and C not visible, so B and C will be written within brackets. Okay, now select this top. You can see we have to give inclination to VP, because here the lamina is resting with respect to the VP plane. We know the concept. If the lamina is resting on the VP plane, means first we have to give the inclination to VP, then inclination to HP. In the same way, if the lamina is resting on the HP plane, first we have to consider the inclination to HP and then inclination to the VP. Okay, that's what the concept. You all know it. Okay, that's what the concept we have to follow. So I'll give angle of inclination here, inclination to VP minus 30 degree. Okay, so check the angle of inclination 30 degree. Okay, now draw projection lines to complete the second position front view. Okay, draw the projection lines. Draw the projection lines here properly. Okay, horizontally also you draw the projection lines. Draw the projection lines. So from each corner ends you have to construct the projection lines. Now write down the notations properly. Wherever the intersection of these top views and front views are merging it, you need to write down properly with respect to the each ends wherever they are intersecting here. Okay, now we can join all these points with a thick line. Okay, so connect it. Okay, now we have to give, you can see the side of the lamina opposite to the corner is parallel to VP and inclined to the HP plane. Okay, here C dash D dash is the end which is opposite to the corner and it is now parallel to VP. Now we have to give inclination to the HP plane here. So I'll give angle of inclination to HP 45 degree. Okay, or 30 degree, whatever it is, because they have not mentioned any angles here, so we have to assume it and we have to construct it. Okay, so select the second position front view, go to move command, creates a copy of it and select the end point C here. Okay, select the end point C. Now go to rotate command, select C dash D dash and place it on the angle line. Okay, now draw the projection lines vertically downward to complete the final position. So draw the projection lines from all these end points. You need to select the end points clearly here, otherwise your final construction will go wrong. Okay, draw the projection lines. So can mention the notations wherever the merging of this top and front views are occurring. You have to write down and construct the final position. Okay, so now you join it to complete the final position here. So we have to start from the A end. You can join it from anywhere, but select it from the key then B, then C, then D, then E, then finally A. So this completes the problem number 4. Okay, now if we, so this extra lines I'm going to remove it by using a trim command. Just you draw a line over the lines which you want to remove, so it will get deleted here. Okay, now you can see in the solution question bank that problem number 5 in projection of planes, problem number 5 and problem number 4 are similar. You just check it out. A pentagonal lamina of psi dash mm has one of its corner in VP and the plane of the lamina inclined to HP. Okay, inclined to VP, the side of the lamina same. The problem number 4 and 5 it is same. So that's why I'm not going to do this problem number 5 here. There is a similarity between the problem number 4 and 5. So guys, make sure problem number 4 and problem number 5 both are similar. Okay, that's why I'm not doing this problem number 5. Okay, so problem number 5 I'm not doing it because both the problems, problem number 4 and problem number 5 are exactly same. Okay, so this is what I have completed for the part 1. Still we have the problems in it. I'm doing in the part 2 video. Okay, so you can subscribe for the channel and hit on the bell icon for the latest notifications and share it to the maximum students so that they can be benefited from this. Thank you for watching the video. Thank you all.